Alright, hey there, Ms. Chauvenet. Here's Algebra 1, Unit 3, Lesson 2. Okay, so we're really talking about slope and what slope is, okay, and how we represent it and how we find it, okay? And really we want to focus on, first off, what is slope? What do we mean by slope? How do we find it from a graph? How do we find it from a set of points? Later on we'll find it from an equation, okay? Alright, so first off, when we're talking about slope, okay, we have 4 different kinds of slope. So even if we did a whole ton of problems, in terms of a linear equation, we've only got 4 kinds of slope. So our 4 kinds of slope outlined in the notes here would be positive. So that positive slope looks like we're going uphill. So that looks like as we go from the left to the right, we read it just like we'd read a word. It looks like we're going uphill. That slope is positive. Then we have a slope that would be negative. So it looks like as we read it from left to right, we're going downhill. So that would be negative. Okay? Then we have a slope that's a horizontal line. So that line's horizontal. That horizontal line has a slope of 0. And then lastly, we have a line that is vertical. So a line that goes straight up and down has a slope that we call undefined. Okay, it is a straight up vertical line. We can't tell you what the slope is. In other words, it doesn't have a definition. It's undefined. Okay? All right. So then again, a slope can be represented by the line or by some numbers. So if we find it by the numbers, m represents the slope. So in equations, later on as we look at it as an equation, the m value is the slope value. What we do is we subtract the y value, so notice it says y2 minus y1, divided by the x values, x2 minus x1, which is otherwise known as rise over run, which is known as vertical change over horizontal change, okay? So how much we move up and down divided by how much we move left and right, okay? All right, so let's look at that and what that means for us. So here we just see a line on a graph, What is the slope? Okay, so what we're going to do is the rise over the run, or what we can call change in y over change in x, okay? All right, so when I first look at this, I see the point, and here, in these ones, they give us points to look at. Now, if they don't give us specific points, you need to pick some points on the line, okay? So here, it starts at -2, -1. So first, I'm gonna see how much I move up or down. So I see that I can count up 1, up 2. So since I went up 2, that's a +2. So I'm gonna put a +2 for my rise. I'll switch colors to emphasize that now I'm working on how much is the run. In other words, how much do we change horizontally? So we move to the right, 1, 2, 3. So since I went to the right, that's a +3. I'm always going to look for if I can simplify. Well, positive divided by positive is a positive. 2 divided by 3 doesn't simplify. So the slope is just 2/3. And that's it. There's nothing else there. Okay? All right, so next, let's look at the slope of this line. So here we see this line. Now again, something you should notice, like when I saw this first one, I knew it was going up. So I knew I should get an answer that's a positive. Now I didn't know it until I actually did the work, but I know what type of answer I should get. Same thing here. I see this line, it's going down. I know I should get a negative before I've even started. Okay, so now I'm going to count again. Now I know I'm counting down. So I'm counting down 1, 2, 3, 4. So I went down 4, so I'm going to put a -4 for my change in y. Now I need to count to the right. So I'm going to count to the right 1, 2, 3, 4, 5. So I went to the right 5. Again, I look to reduce. Now, you don't want to change it into decimals. You'd rather just leave it as a fraction. 4/5 doesn't reduce. A negative by a positive is just a negative. So there we go, -4/5. And again, that makes sense because we knew right away that line was going down. So it had to give me some kind of a negative answer. Okay, so that's what I do if I'm given the graph. I look for what's my change vertically, in other words, going up or down, divided by my change horizontally. And basically, we're always going to look to count to the right. So we go up, or we go down, and then to the right. All right. So then from there, what do we do when it's just a set of points? Okay, so we saw in the previous definitions back here that we could also do it by y2 minus y1 divided by x2 minus x1. Okay, so what the heck does that mean? Well, remember, coordinate points are written as x comma y. So the first value is the x, the second value is the y. Well, this is my first set of points, and this is my second set of points. So when we say y2 minus y1 over x2 minus x1, well, my y2 is my second y value. So my second y value is the -2. So I'm going to plug that in. Minus Well, now I need my y1. My y1 value is the 0. So there we go. Now if you want, you can just go ahead and do this now. So negative 2 minus 0, obviously, subtracting 0 does nothing, so I still get negative 2. So now for my x values, well, my x2 is my second x value, so that's the 3 minus, and now I need my first x value. Well, my first x value is the negative 1, so 3 minus negative 1. Now again, let's make sure we're using those skills, right? Minus a negative, really the same as a positive. So this should really be 3 plus 1. So now I bring the negative 2 over, 3 plus 1 is 4. But now I always want to look to say, can I simplify? So if I have negative 2 over 4, I want to divide those by 2. When I do that, I get negative 1/2. So that's how I find that slope between those points, okay? So we looked at finding the slope from a graph. We count up, positive, or down, negative, and then to the right. And then we divide it and simplify, okay? And then we just found it from a set of points. We do the y values, we subtract them, then the x values and subtract them. y2 minus y1 or x2 minus x1. We simplify and reduce if possible. Okay, so then last but not least, what if we have the point and the slope, but we want to draw it on the graph? All right, so we're going to start out with what our point is, which in this case is 2, 1. So we're going to go right 2, up 1. And now we have the slope, which is 2/3. So let's just remember that's rise over run. So from this point, I'm going to go up 2, right 3. So up 2, right 1, 2, 3. Boom. Now, if I want to, the same way I went up 2, right 3, I can go down 2, left 3. That would be the equivalent. So down 2, left 3. So there we go. And now, as always, here we're going to throw a line through it with arrows. Okay? All right, so one other one here just to see, it's not really a new skill, but just what if you're given a table and you're asked to find the slope? So really here you have a whole bunch of x and y values. We still need to do the y minus the y over the x minus the x. So I'm just going to demonstrate this one to show I can pick any sets of points. So the first time I'll do 2 and 11 with 0 and 7. Okay, so I'm going to do 11 minus 7 for the y's, so 11 minus 7. And then I'm going to do 2 minus 0 for the x's. Well, 11 minus 7 is 4, 2 minus 0 is 2, 4 divided by 2 is 2, so the slope would be 2. Well, now notice I'm going to pick just a different set, so I'll use 1 and 9 and negative 1 and 5. So I'm going to do y minus y over x minus x. So 9 minus 5, well 9 minus 5 here, again, that's going to give me 4. 1 minus negative 1, so 1 minus negative 1. Well, 1 minus negative 1 is like 1 plus 1, which is 2. 4 divided by 2, oh, still 2. So again, on each of these examples, when I'm given a table and I'm determining the slope, you just need to pick 2 sets of points, and then it won't matter. Either set of points, they should give you the exact same slope. Okay, that's a summary for Unit 3, Lesson 2, Algebra 1. Hope this helped.